All right, so in our last video, we looked at balancing a redox reaction in an acidic solution, right? This was the end result of what we got for our balanced chemical reaction for an acidic solution. And how do we know that this is an acidic solution, that we balanced it? We have these H+ ions there. Remember, if we have an acidic solution, we have an excess of our H+ ions. Well, we want to look at, well, what happens if we actually balance this in a basic solution? Okay. Well, if we have a basic solution, we don't have an excess of H+ ions, right? We have an excess of hydroxide ions. So it wouldn't make sense for us to write out a balanced chemical equation dealing with an excess of H+ ions. Okay. So what we can do is we can go ahead and balance it like we would in an acidic solution, and then we're going to do an extra step. What we're going to do is we're going to realize we don't have an excess of H+, we have an excess of hydroxide. So what we do is we take our balanced acidic solution, chemical equation, and what we do is we are going to add the number of hydroxide ions that is equal to the number of H+ ions we have in our chemical equation. So as long as we do that to both sides, then what we can do is we can say, well, it's still balanced. So we're going to take our acidic balanced equation where we have 5 copper, 16 H+, and we're going to add the same number of hydroxide as H+ ions that we had. So we'll add in our 16 OH- ions. Now we're going to do this to both sides. Okay, and then we still have our 2 permanganate ions. Okay, this is going to yield, okay, I'm going to add in those 16 H+ that we added. Our OH- ions for the 16 H+ that we had, and then I'm going to go ahead and fill in the rest of what we originally had there. So 5 Cu2+ plus our 2 manganese 2+ ions and those 8 water molecules. Okay, so now we can't just stop there, because we should realize, right? Remember, if we see H+, OH-, what does that mean, right? This is an acid and that's a base. What happens when we put an acid and a base together? Well, they don't just stay apart from each other, they combine to give us water, right? So out of this, we would get 16 water molecules. Okay, for every H+ and OH- that combines, we get 1 water molecule. So now we see we have 16 water molecules here, not our 16 H+ and 16 OH- ions. Well, we want to finish up by realizing we got water molecules here, we got water molecules here. Let's go ahead and reduce that. Well, we have 8 water molecules there. That is no longer 16 now. That becomes 8. We take 8 of those away, right? However many we start with. We can just simplify. And now we end up with our overall equation of 5 copper plus now our 8 water molecules plus our 2 permanganate ions. And that's going to yield our 16 hydroxide ions plus our 5 copper 2+ ions and our 2 manganese 2+ ions. So now we've gone ahead and balanced our reaction in a basic solution. And the way that we can know it's basic solution, right? We have those OH- ions there present, because we know a basic solution has an excess of hydroxide ions. So now we're able to hopefully balance acidic solution redox reactions and basic solution redox reactions.